Hello, my name is Daniel Guil, and this is my EET 402 capstone project for Dr. Ali Setoodinea. This project consists of a digital lock that I've implemented this Motorola 68HC11 microcontroller to implement this digital lock. The two main components for this digital lock consist of this 4x4 membrane keypad and this LCD display. What I've done here is I've used two sample programs from EET 430, which consists of the keypad 4x4 program and the LCD 2 program. What I've done to those programs is I've added approximately 250 to 300 lines of code that will demonstrate this digital lock. One of the main components that I've done here is I've added 4 pins to reserve the memory bytes for the digital code. This consists of a 4-digit security code that will be entered here on this 4x4 keypad and will display a message here. The messages will vary depending on the correct code is entered or the incorrect code is entered. I have several delay routines in this program, and those delay routines, they have to do with this entering your code here on this keypad. For example, there's a 2-second delay routine. Most individuals that use a digital lock, they have a pretty consistent time in between numbers. Say for instance, if you press and hold a number too long, in this case it's going to be 2 seconds, then an incorrect code message will appear here on this LCD. I did implement a small loop in this program to just hold the display message, if the correct code is entered. The lock will be unlocked during that time period, and you'll have to press the numeric 1 on this keypad to continue with any other features you may want to implement on this digital lock. In addition, once the lock is unlocked, you can press the numeric 5 on this keypad to lock it once again. We'll go ahead and get started, and I'll give you a demonstration of how this program is designed to operate. Okay, we started running the program. The program is run, and we can see on the display that system locked. Enter unlock pin. From this point, you're required to enter the default security code, which is 1234, which is basically standard for most digital locks. In most situations, you can change the default code, and most users will change it to something they can easily remember, such as a birthday or a year, for example. Okay, and we're going to enter the default security code of 1234 on this keypad here. Then we'll observe the message that will be displayed. Welcome home, Daniel. That's displayed on the LCD as it should be because the correct security code was entered. Okay, now we need to press the 1 on the numeric keypad. We're going to press that, and the system unlocked. Press 5 to lock. Okay, we're going to press the 5, and once again we can observe that the system is locked. So what we're going to do now is I'm going to demonstrate, say for example you hold the key too long, and we'll see what kind of display we get. I'm just going to use the 1 key for example, and I'm going to hold it longer than 2 seconds. Say we'll count to 3, and we'll observe the output on the LCD display. And we see we got the correct display there on the LCD, and the system remains locked. So we'll enter the correct code, 1234, and there we go again. The system's unlocked, we'll need to press 1 to continue. We press 1, system still unlocked. Press 5, system is locked once again. In addition to the timing delays on this keypad, what I've done is also there's a 2-second delay between the numbers. Say for instance you're using 1, 2, 3, 4. If you go from 1 to 2, 2 to 3, 3 to 4, if you use longer than 2 seconds to go from 1 to 2 or 2 to 3, 3 to 4, then that same display message will appear on the LCD that says incorrect code. I'll demonstrate this feature, and we'll go from 1 to 2, 2 to 3, and then we'll pause for longer than 2 seconds. 1, 2, and we see we got an incorrect code because of the timing delay. Once again, we'll try this. 1, 2, 3. Once again. Okay. I think that fairly demonstrates the timing delay works efficiently. Now we'll go ahead and enter the code and get this unlocked once again. And we got the display message. The digital lock is unlocked at this time. Okay, one of the other features that I want to demonstrate here is if you input the incorrect code, which basically is going to display the incorrect message on the LCD. Say for instance we just use 4, 3, 2, 1. We'll go backwards. Okay, we're going to press 1 to continue, 5 to lock. And the way this is designed to work is in the program I set pins to reserve the memory bytes for these numbers here. And what it does, it will check the stored value of that number, and if it's incorrect, it'll display the incorrect code. So we're going to go 4, 3, 2, 1 and see how long it takes. 4, 3, and basically at the second number it already recognizes that that's going to be the wrong code, so the system remains locked. And that basically concludes what I've done with this program. As I've said, I used those 2 sample programs and only really had to add basically 250 to 300 lines of code to make this work a little differently. I've really enjoyed doing this project. It's taught me a lot, and I just look forward to continuing on and learning more about how to do this assembly programming using this microcontroller. Thanks for viewing, and I wish you all much success.